So now that we've talked about some of the core factory method operators, transforming operators, action operators, and suppressing operators in the mono class, let's put all the pieces together and take a look at case study EX1. And this is going to show what the key operators are in the mono class and then apply them in a detailed case study. You can find the case study here at this link, and it demonstrates the use of just, fromCallable, map, doOnSuccess, and then. And we're going to walk through that code here in just a second. So if you go look at this code, you can see how it all works. So let's go look at the code. So here is the EX1 project, which is in my GitHub repository in the mono folder. And we're going to go ahead and take a look and see how it gets used. So what we're going to do here is we are going to walk through the test driver first. Every one of these programs has a test driver. And you can see what the test driver does. It just goes ahead and it registers a couple of test methods with the async task barrier. Remember, the async task barrier is this barrier synchronizer that waits for everything to be done before it returns. We'll see how it gets used here. So we're going to go ahead and register a test method called test fraction reduction sync1 and test fraction reduction sync2. And the reason why it says sync is because they're synchronous. We haven't introduced asynchrony yet. We'll do that next. And then what we're going to go ahead and do is we're going to, once we've registered these two test methods, we're going to tell the async task barrier, start all the wheels in motion, get all these tests to run. And then that will return a mono, and we're going to block until all the computations are finished. So the calling thread will block until all the computations are done. Once the computations are done, then we print out the results and we'll indicate how many tests were run and how many tests were completed successfully. Now, in this particular case, because both of these test methods run synchronously, we actually, when run tests is called, it'll actually cause each of these things to block in the callbacks. And so block doesn't actually get called here until all the other calls are done because they're done synchronously in a single thread. But if they were asynchronous, then they would run in the background and we would block the calling thread. So let's go ahead and take a look at these two methods. Let's go over here to monoEX. And this is the class that has those test methods in it. We're going to define a field called S unreduced fraction, which as you can see is a big fraction with two big integers as its numerator and denominator. And here's what the numerator and denominator look like. They're just strings of very large big fractions. And we start out with non-reduction. We say, make me a big fraction is not reduced yet because we're going to reduce it as part of the test. So we come down here and take a look first at test fraction reduction sync1. This is kind of a bit of a verbose way of doing things, just kind of illustrating how it works. So the first thing we do is we're going to make ourselves a string builder. A string builder is a class that can be used to append strings, and we're doing it in a single thread, so we can use a string builder. String builder has no concurrency or thread safety to it, so it only works in a single threaded example, as is this one. And we're going to use this to print all the results so that we can print them out when we're all finished. So we go ahead and we say mono.just. Remember, that's going to run in the calling thread because it's an eager operation. It does the operations at assembly time when the code is instantiated, when the chain here is instantiated. And that's going to go ahead and take the unreduced fraction that we defined up here, and it's going to reduce it in the calling thread, so it's all synchronous. We're then going to use doOnSuccess, which is going to take the big fraction, and it'll go ahead and basically append to the string builder some diagnostic information. It's going to say unreduced fraction. It gives the string version of the unreduced fraction, and it's going to reduce the improper. It'll say it's reduced improper fraction. We can create the big fraction to a string, and then we're going to call the big fraction to mixed string. So we're just kind of printing out some diagnostic information, which you'll see when we run the program. We then use the map method to convert that big fraction to a mixed string. So it's doing type conversion from big fraction to string, and it's also, of course, giving a different value back because it's reducing it. I'm sorry, it's making it a mixed string, a proper fraction as opposed to an improper fraction. We then use doOnSuccess a second time to go ahead and append the results. So we're going to take the results, which comes in here as the parameter to doOnSuccess, which is the string that was created by mapping to mixed string. And then we also go ahead and display the result after converting the string builder to a string. So we've been appending. We now create a string. We call display. And display simply goes ahead and prints the result, indicating the thread of control of the caller. And you'll see that it'll just be thread 1, thread ID 1. So now we're done. We've basically done the creation of the big fraction, the reduction of the big fraction. We've done the mapping to transform it to a mixed string. We printed out some diagnostics with doOnSuccess, the action operators. And then we just go ahead and use then to indicate that we're finished. So the async task bearer framework knows we're done. Let's take a look at test fraction reduction sync 2. Very similar, just kind of consolidate some things so we don't have quite as much verbosity here. Let's look verbose. So what we're going to do is we're going to use string builder to make our buffer that's going to keep track of the results we append to it. This time we're going to use fromCallable. Notice up here we used just, where we had this call take place at assembly time. Down here we're going to use fromCallable, which provides it basically a callable, which is lazy as opposed to eager. So that's going to go ahead and do the reduction at runtime. Doesn't really matter for this example, but if we had multi-threading, it would. We then call doOnSuccess. This time, instead of writing everything out longhand, we're going to make a call to a method called log_BigFraction, which just kind of hides all those details of adding the elements, adding the string, appending the string to the string builder. We then call toMixedString, and then we use doOnSuccess to display the mixed big fraction. And again, that just consolidates that code in a nice little function form, so it's a little cleaner. So I think you'll probably agree that this code is ever so slightly easier to read than this code, which is just ever so slightly more verbose. Neither one is right or wrong, just one is a little bit more refactored. And the last thing we do here is we use .then to indicate that we're done. So armed with that knowledge, let's now go ahead and run the program. And we can see the results. A couple things to note. Notice how everything is done in the main thread, which is thread ID 1. And we're going to call test fraction reduction sync 1, test fraction reduction sync 2. In both cases, we took an unreduced fraction and we reduced it to a reduced fraction. So this particular gigantic big fraction that's unreduced gets turned into 9 halves. And then we converted that to a mixed string, which was 4.5, which is what you'd expect if you remember your fraction math from probably 6th grade or something like that. And notice how both these things work exactly the same. They give you the same output, and everything is running in the main thread. So remember that, because when we talk about the next set of examples, we're going to see how we can start moving computations to the background thread. This particular case study is intentionally designed to be very simple. I wanted to introduce operations that you could have a relatively good feel for without having to know a lot of stuff. So we focused on the core factory method, transforming, and suppression operators that are part of the mono class.